Welcome everybody to Pollinators and Climate Change Considerations with Athena Contus. Athena has been keeping bees in the Sandwich Mountain Range of New Hampshire since 2008. She serves on the board of the Winnipesaukee Beekeepers Association and is a teacher of apiary management through the Carroll County, New Hampshire Adult Ed program. She received her Master Beekeeper certification through the University of Montana, the long history of cold climate honeybee research, while continuing her education through the Cornell University Master Beekeepers program. We are so grateful, Athena, for your willingness to share your expertise with all of us. Thank you.
Oh, thanks for having me. It's always an educational experience for me to put something together. I appreciate the introduction. The University of Montana has a pretty sophisticated beekeeper training program, and I thought I had bitten off a little more than I could chew. But I'd like to share some of the things, some of the insights I gained going through that program, and I believe has given me the confidence to give such a presentation as this. I wanted to point out, I will give a link to this, to the work of this artist who did this beautiful watercolor. It just seems to say so much about the diversity, and it's based on this James Webb Space Telescope art competition and display that they did. Anywho. Climate change and bees. Beekeepers work up close and personal with bees. They do allow us a window into a very unique world in a very unique way, where you are handling their brood nest area, you're handling their food. They are rather independent, but there are a few things a few points I thought to help me stay on point. I want to go over some of the scientific studies. I have to say about this, I've been so impressed with people who are answering the call of their times. I like to say that because I just think we're so lucky that there are people who are interested in these things. And not only that, but dedicate their lives to the study of it. And not only that, but have the wherewithal to share their findings with us. I want to go over some of the New Hampshire ecosystem historical losses and some of the recovery. And then there may be a smattering of this throughout the presentation on the impact of climate change and what we might learn from managed bee colonies and our New Hampshire pollinators. These are just a few of some of the brilliant people engaged in honeybee and pollinator research. And at the end of this presentation, I'm providing a link to a little newsletter I put together with links to some more information about these studies. Diana Cox Foster has done a wonderful article on the impact of climate change in bees, but she's also been engaged in working with young scientists at the university level out in the field, observing and gathering data to determine how different pollinators work together in not just a pristine ecosystem, but in one that is disturbed in a national park where there are a lot of different recreational activities going on, and where there's cattle and sheep grazing going on. And over several years, they've gathered some wonderful data that just illustrates how well nature can rebound, and how well these pollinating insects, native bees, and they brought managed bee hives into this environment and cataloged what was going on between the native bees and the managed honeybees. It's a fascinating study, and David Holloway down here below, he did similar studies on this. Heather Matilla is at Wellesley College. She's been doing some great work on wasps, and but her emphasis is honeybees, but she's an up and coming star in beekeeping science. Samuel Ramsey just shattered a lot of old thinking about bee mites, which are probably the biggest challenge beekeepers are facing right now. This is a study he did in 2017, just really helped us all in managing our colonies. Of course, Professor Tom Seeley has written some wonderful books on monitoring bees in the wild, and I'll share a little bit of his research as we go. Professor James Fraser, he's retired now, but he did about an 8-year study on chemicals in the environment and how they find their way into bee hives and how they accumulate in the hive. Dave Golson is a wonderful author and speaker, and I'll link to a talk he's given on this subject. And Kristen Trainor, wonderful speaker. I'll provide a link to one of her talks you're sure to enjoy. And they're all looking at everything from, in Kirsten's case, what is the chemical content of the pollen being brought in on a state-by-state basis? Which state has the most contaminated pollen? And they have found as many as 22 different garden and agricultural chemicals coming in to beehives. And speaking of that, Jerry Bromenshank, he was my advisor at the University of Montana. They have a long history of cold climate beekeeping research, and he developed a way back in the early 2000s on how to map areas of the country that have that they rate according to the toxins found in beehives around the U.S. So great group of people, and generously share their findings with the average beekeeper. It's been a wonderful support. Now, the thing I was challenged to do at the University of Hawaii that pertains to or that sheds some light for me on what climate change might mean. And I really thought, I'm not going to make it through this course, because they wanted me to look at scientific studies and evaluate the differences between them and put the data into charts and spit those charts out and then write a review of what I'd found. And I was really ready to just shut down right there, but I'm so glad I stuck it out. And the main reason I think I was able to do that was because I did know of a scientific study, a paper, a peer-reviewed paper that had been published by a beekeeping teacher I had at the University of Southern Maine. She had done a study on whether it mattered if you had bees that were acclimated to our climate. She was concerned about parasites coming up with bees that beekeepers were buying from the southern states. And so she wanted to show some data that bees could overwinter up here and stay healthier longer if they came from colonies that were raised up here. And our advisor, Jerry, he encouraged us to find something we felt passionate about and had some experience with to help us do this project. So I found some folks in Pennsylvania that took offense that Aaron in Maine was saying, hey, stop shipping those bees up here. And so they did their own study of northern and southern bees. So I understood the subject matter, and that was my foot in the door. And so I put the data in and spit it out, and I found this chart to be pretty impressive, a pretty impressive difference. These are the average daily temperatures the year that Erin did her study. And these are the average daily temperatures that the Pennsylvania group did theirs. And there's a temperature difference of 10 to 15 degrees throughout the entire year. And so that's pretty significant to a bee. Honeybees can only comfortably fly at about 57 degrees. And if you can see from this chart, that gives them dependably maybe only 5 to 5.5 months of flying temperatures. Then they cluster like penguins. They don't hibernate, but they are moving around in the hive and maintaining warmth that can help them survive through the winter. They share food that they have stored with that intent in mind. In Pennsylvania, you can see they have many, many more months of flying weather to gather in food stores, and a shorter winter that they have to have that food stored for. So that was pretty fun to do that. And I didn't do the actual field testing like these folks did, but just so glad that there are people interested in these things and doing this sort of data collection. I feel like before we move forward, we do need to understand some terms. You often hear about habitat loss being the number one reason we're losing our insects. But what is a habitat? I really think we may be talking more about losing whole ecosystems. And the National Geographic defines an ecosystem as an area where plants, animals, and other organisms, as well as weather and landscape, work together to form a bubble of life. And that's really what we hope to be able to nurture in nature. A habitat is, it's an area of that ecosystem or part of that ecosystem that contains everything an animal needs, such as food and shelter. And then on top of that, there are these little microhabitats that are small areas that differ somehow and may be home to unique species that are not found in the larger regions. I want to talk a little bit about what happened with habitat loss and ecosystem disruption. And this pretty much tells it all in a way. In 1900, the US population was only 76 million, or less than a quarter of what it is today. It only took 100 years to get to this. Little calculator is on the line and it's in real time. It's fascinating. It drops with deaths and it increases with births, and it'll break it down by the state for you. It's a pretty fascinating thing, and I'll provide a link for that in the newsletter. But to think that all of these people, and they actually do break down this population by immigrants versus births. in 100 years, we had over 300 million people to find food for. We didn't have 300 million farms to grow food. We had to come up with something. And also, as we moved across the country, we began to build homes to provide shelter for these folks, my immigrant ancestors included. In New Hampshire, it was a state 90% covered by usable timber. And they just began clear cutting it down to 45% of was left of the forested land. Now it has rebounded, and we are now, according to the USDA, we're up to 80%. The wonderful, unique thing about New Hampshire's forest, and without even knowing the science here as a beekeeper, I recognize this, I think, in my second season of keeping bees. Bees love tree flowers. It's like acres of food to them, one tree. And in this climate of New Hampshire, it's really the perfect climate and seasonal temperatures to provide both evergreen and deciduous trees. An oak tree alone can support over 280 species of insects. And it's interesting to note that the trees in our forests today are probably no more than 100 years old. The first settlers came up here in the 1600s, and there was little attention given to identifying species of insects and plants, if any attention given. And there were no conservation efforts going on during this period of time. One researcher, Kelly Birch, said logging wasn't just an industry, it was a way of life for New Hampshire residents. But then I think it was the Weeks Act that came out in 1910, and there were local New Hampshire folks interested in doing something about this before we lost all the wonderful things that New Hampshire had in nature that we had yet even been able to catalog. Might have a slide or two out of sync with this narrative, but we'll move along. So mixed forests occur in areas with distinct warm and cool seasons, and in New Hampshire, that is on average 37 to 73 degrees throughout the season. Those are the swings that favor this very rich and diverse deciduous tree growth going on here. As the state begins to warm, what we're concerned about is that these trees won't do so well, that we may not see the diversity that New Hampshire has enjoyed. It can potentially weaken the plant populations that pollinators and other insects depend on. There will be shifting growing and bloom seasons. And also the warmer temperatures will definitely alter migration patterns, affecting pollinator species like butterflies, and certainly impacting the bird populations that feed on these insects. There's going to be some things out of sync. We can only hope that nature is resilient enough that it can find a balance. And I mean, like it obviously did come back to where New Hampshire does now have 80% its woods back. But we need to keep in mind that a lot of plants and insects were lost that were part of the original ecosystems. So when we try and restore ecosystems, there are always going to be missing pieces, like putting a puzzle together and not having some parts join other parts because of the missing pieces. Excuse me. This is 100 acres on Ferncroft Road. We lived there for 20 years, and it would always amaze me. You could take a picture from the same vantage point and see so much diversity depending on the season you were standing there taking the picture. This is one year we had a remarkable, excuse me, primrose bloom. In the fall, the goldenrods and the asters come in. We had wonderful milkweed and monarch butterfly migrations here. And this land at one time was cleared and left to its own devices. This is what came back. So it's not impossible to hope. It won't be what it was exactly before. And I think we just need to remember that when we talk about planting native plants and encouraging native species, we need to keep in mind that in history, these ecosystems had all the moving parts to work together and to be successful. And so we will see failures as we try and do that, as we try and bring back ecosystems. But that just means there's something not there that used to be there, and there may not be any way to get it back. So invasives do come in and fill niches, but we just need to be aware that we don't know everything. We're not all knowing, and no study is ever going to be 100% conclusive. But as I tell my beekeeping students who feel a little overwhelmed sometimes, all we can do is the best we can with what we know and move forward from there. It's really all we can do. There are studies that indicate the insect mass within nature has declined 70 to 80% over just the last 30 years. And that's due to human impact of, developing land, but also all the chemicals that we use in our gardens. And that's not just pesticides, that's fungicides, herbicides, chemical fertilizers. As the Kirsten Taynor study showed, over many years collecting pollen from different states, she found up to 22 chemicals in just one pollen sample. And there's some other results similar to that. A very interesting, very magical thing, I think, that happened when all this clear cutting was going on in New Hampshire. The settlers really didn't understand pollination, but from the earliest cave drawings, humans have used bees. And it was only natural for when the European settlers came over in the 1600s that they brought with them their favorite honeybee, which was the Eastern European black bee. Sometimes you'll hear it called the German black bee. These bees found a wonderful haven in the northern forest of northern Maine, Vermont, and New Hampshire, and upstate New York. It was similar to the climate they had come from, and they moved into these areas and became sort of a supplemental boost to a ecosystem that was disappearing. And studies are showing that they actually kept plants alive that were losing their native pollinators, and also providing little micro habitats for the pollinators that were being so terribly disrupted with all of this logging going on. Even today, they find them to be a keystone species in the wild. And I'm talking about wild honeybees. They are not native to North America, but they have made their home in the wild here, especially in the Northeast. And so what happened with the growing populations across the country and our need to feed these animals, and I might be my next slide here. No. Okay, I'm going to keep talking on this one. Let's see, it really wasn't until the 1800s that we figured out how pollination worked, and it was very fortuitous because a lot of the foods that we depend on now that were brought from Europe, and coincidentally, they did so well, and they did so well because the settlers had also brought their native pollinator with them. But the settlers didn't make that connection until the late 1800s. So what about the native bees? And all bees intentionally collect pollen because pollen is a food source. It's a protein source, and it's needed for raising a brood. But other pollinators are sort of accidentally spreading pollen around. They're coming to the flowers for the nectar. But of our bees, we have 70 species of sweat bees. And these are these little teeny tiny bees. You see them sometimes with pollen on their legs. 30 species of leafcutter mason bees, 5 species of carpenter bees, and 10 bumblebee species. And 70% of these native bees are ground nesters, and the remaining 30 will nest in cavities. And these are the bees that like the hollowed stems of plants to lay their eggs in. And you'll see these little native pollinator houses that have a bunch of holes drilled into a block of wood. They are solitary bees. They don't overwinter as a family. The honeybees and those German black bees that are in our northern woods, they are the only pollinators that overwinter as a family. And in our climate, that is usually maybe about 30,000 bees. In the south, honeybee populations can get up to 80,000 bees during peak foraging season. But in our climate, our bees seem to be, and also as long as the beekeepers are sourcing bees that are acclimated to our climate, we're seeing very conservative colonies that are very good at putting away food for a long winter and very good at conserving food. In the solitary native bees, only the queen will overwinter. So in the spring, you'll see these big bumbles, and that's the mom. And she's out there building her nest and collecting pollen, and she'll lay her eggs on these little pollen balls. They actually mix the pollen with nectar and moisture, and they actually let it ferment. and we beekeepers call that bee bread. And they make it palatable for the larvae. And then once her daughters become capable, then they run the show, and she stays home and lays the eggs. So we are able to get a glimpse of what life is like for bumblebees. We aren't really lucky enough to get a glimpse into the lives of some of these solitary native species. But honeybees have opened our eyes to the fact that they can live very complex lives. And really, there's just no end to how fascinating they are. New Hampshire is home to 6 insect pollinators and 1 vertebrate. And the vertebrate is our favorite little hummingbird here, our only little hummingbird here. It's the only hummingbird east of the Rocky Mountains, but she's looking for nectar, or he, and just by accident will get pollen on him, and then we'll spread it to other flowers. So these flowers are giving nectar as a reward because they want to be pollinated. We have moths, butterflies, bumblebees. We have a native wasp, the digger wasp, and we have let's see, I write that down. Very important. Most of our pollinators are specialists. I think most folks know that monarch butterflies need milkweed, and their larvae will only eat milkweed, and they can only reproduce if they have milkweed. The tiger butterfly here in this picture is more of a generalist. And I think I'll come back to this. Oh, I guess I took that slide out. I'm sorry. We'll get to it. I want to explain what pollination does and why it became so magically available. I mean, or how magical it is that it did become available to us to understand insect pollination. This is the difference between a thoroughly pollinated plant that produces edible fruit, beautiful, well-rounded fruit. This is not produced because of chemicals. This is produced because of the way bees pollinate. I took this little film when I was on Crete. My cousin set up a wonderful tour where we visited beekeepers, and we just did wonderful things. And I was surprised to recognize so many plants in Crete that I had seen here in New England. And in this picture, this flower's native pollinator, but I want to show you how thoroughly she's gathering up that pollen. She's leaving nothing behind. She's really going for it. And I was saying once to Kelly Goodson, when I came back, I was showing her this film, and I said, "Look at that bee work that flower." And she said, "Oh no, look at that flower work that bee." So this is why, especially bees that produce large populations are so great for the kind of agriculture that we do. We can't just, so far haven't figured out any way. It would be nice in a perfect world, we all hope for, that someday we'll learn to farm that works with nature and works with our native pollinators. But with over 300 million people depending on different ways that we package food and food supply chains, we know from COVID what happens when a food supply or any kind of supply chain breaks down. It's not just produce disappearing from the produce section, it's canned goods, factories that can those vegetables and fruits. The frozen section, it would be disastrous. So there's a lot of talk about transitioning to using a diverse pollinator network, but it's a huge hurdle. But I would like you to appreciate this about how a flower is pollinated. They're pollinated much more thoroughly by bees because bees want to eat that pollen. So they're really in it for the goods. They're not just getting a sip of nectar. Some plants they do, and not all plants produce both nectar and pollen. But pollen is especially important or they can't raise their young, whether it be honeybees or bumblebees or these solitary bees. And then just some interesting facts, and I may have already said this, that these are plants that were brought over from Europe, and even those that are self-pollinating benefit from bee pollination for that very reason, that you'll have a much more well-formed fruit. So honeybees are the native pollinators of peaches and pears and walnuts and coffee and grapes and apples. Apples came from Asia. I know they seem all American, but they actually came from a part of the world where our managed honeybees in beehives are their native pollinator. So having an appreciation for that, I think it's important to we're going to find a balance in this narrative. I think folks that have for many years advocated for native insects and native pollinators and worried about invasives, I think they kind of felt like honeybees were stealing the show with the media. And so to make the argument that the native pollinators are just as important, which they are, for a variety of reasons, I think that people who know the science of agriculture, of modern agriculture, get it. But there's a lot of folks that come up to me at farmers market and right out of the ballpark, they tell me I shouldn't be a beekeeper because I'm stealing food from the native bees. That's just not a fact. There are circumstances, and in every master beekeeper program I've been in, 3 of them, there's a great emphasis given to beekeepers to appreciate the number of hives that are realistic to have on a property and the urgency to cultivate your land to grow plants that will feed a whole host of pollinators, and to always be mindful of those facts. I've been very impressed with the emphasis on that in training beekeepers. So that is the narrative that gets tossed around, and I'll give you a link to a talk by that Kirsten Tainer about that. She goes over some of the headlines that we see and traces down what the origins of those headlines might be. It is very important for beekeepers, if you're a beekeeper, to be responsible. We recommend normally 2 hives per acre and no more than that. And that if you are really serious about raising bees for honey, that you plant a lot of good nectar plants on your property. And there's a lot of support and guidance to help you do that. Okay, so what is the New Hampshire Fish and Game doing to help pollinators? They manage over 60,000 acres of wildlife area, and they are dedicated or coming up with ways and working with different organizations to promote successional habitat. They did a survey in 2020 to assess the current condition of animal habitats across the state. And I'll give you a link to their site where they state all their goals, which are very interesting. They have a goal to have one registered monarch way station in every town in the state, which is fabulous. These butterflies need connected areas when they migrate. They can only go so far without having to stop and refuel. They want to help create pollinator habitats through the schoolyard habitat grant, which is really a neat program. And conservation measures such as delayed mowing, removing invasive species, and planting native flowers will be implemented to improve managed areas for pollinators. And then they share their data with organizations like the Monarch Joint Venture, the Xerxes Society, and of course the University of New Hampshire Extension. The New Hampshire Wildlife Action Plan, it lists things that are dangerous to our natives. Climate change, which will bring about earlier flowering times and may decrease the availability of food and forage. We don't know everything about this. We don't know how well everyone's going to adapt, but there are concerns. One of the biggest problems, as I mentioned, chemicals, more frequent pesticide use is killing pollinators and non-target insects as well. And then continued habitat loss from development can remove essential nesting and foraging habitat. So what can we do in support of the New Hampshire's Wildlife Action Plan? I think it'd be great to have somebody from that plan come and speak to this group. But we can protect existing pollinator habitat, just be mindful of it on your own land. Pick the right plants that they love, grow the right plants from seed using a perennial native flower mix. American meadows, they have good untreated, uncoated seeds. You don't want coated seeds, and you don't want plants from commercial growers because they inevitably are using all the wrong things to grow their plants. So if you can grow from seed, or a good organic gardener is the best way. So there are a lot of pamphlets I'll give you a link to on how you might apply these principles. Reducing mowing. Mowing doesn't just eliminate flowers. Mowing can chop these insects up into little itty bitty pieces and damage them, kill them, eliminate them. I've had my bees mowed down in a field in the fall when they were all over the goldenrod and asters. When I had my shop in Ospey, I'd get calls. Usually I could bank on it. Second week of September, my bees are gone. So, well, where were they foraging? And was there any mowing going on this week? And oh yeah, that's usually the case. It's a domino effect. If the foragers get mowed down, the younger bees try and rally to go out and get the last little food in before winter sets in, and they are not physically developed enough to do that. They're young, and the presence of the foragers keeps them home and developing their ability to fly, their ability to see, their ability to navigate. Their brains aren't even fully developed. So if they leave the hive, we call this dwindling. It's a phenomenon in beekeeping, and it usually happens in the fall. Something happens to the foragers that are out in the field trying to get that last little bit in. And then the temperatures start dropping and the days are shorter, and the young bees go out to try and pick up the slack, and they get too cold to fly home, or they get lost. And all you've got left in the hive then, and this can happen in 5 days. That's all it takes. You can have 40,000 bees in a beehive, and 5 days later have just a queen and a handful of young bees. And that's called dwindling. Not very well understood phenomenon, but they've been working on that problem in Germany for at least 15 years. I didn't hear anybody talking about it here in the US, but there are these wonderful people who answer the call of their times. And this beekeeper, who is the head of he was the president of the German Beekeepers Association, he started working with this gal who was designing pollinator-friendly mowing equipment. And then they got somebody else on board who came up with the idea to do a pollinator-friendly dairy label for any farmer who purchased and used this equipment and obeyed these mowing guidelines. And he gave a wonderful talk at an international conference. There are a lot of wonderful organizations now, and it's really cool that they upload these lectures online. We've just come so far in the spreading of information. I feel like I might be running over time. Am I good? Juno, do I have more time?
Yeah, a little bit, and then we could transition and have some time for questions.
All righty. I think I just have a couple more slides. I did want to point out that New Hampshire does have a state butterfly that's endangered. It's called the Carner blue butterfly. This is a butterfly that needs native lupine to survive. And there's our eastern tiger swallowtail, which is more of a generalist. And then there are some recommendations on how to help pollinators by, just mowing part of your lawn, planting native flowers, shrubs, and trees. One thing about this is a wonderful, well-functioning ecosystem needs more than just flying insects. There are beetles and other insects that want to eat the leafy parts of these plants and depend on these native plants. This is a gal in London who was following a practice going on in France, where people were naming the weeds that were growing up through the cracks in the pavement to help bring awareness to the fact that weeds are, one of these folks said, if you want to get rid of all the weeds in your garden, just call them wildflowers, and that'll do it. Insect mass within nature, as we mentioned, has declined 70 to 80% over the last 30 years. And this is, interestingly enough, France banned pesticide use in parks, streets, and other public spaces in 2017. And they banned the use of pesticides in gardens in 2019, trying to bring awareness to this situation. So planting keystone species, I think I've got, I'm going to skip over this. We've sort of talked about this. something that beekeepers need to be aware of is that the increased heat that we had and the drought that we had over the past 3 years, I feel like we're recovering from a severe drought. That my queens all stopped laying. I went through 8 colonies. They all stopped laying. A beekeeper is told when their queen stops laying, there's something wrong with the queen. But in this case, it was the heat. Bees are very temperature sensitive. It does impact their ability to reproduce. They need to keep the brood nest at about 93 degrees, and they know if the heat has dropped less than a degree or if it's gone up a degree. And all these bees on my hive here have crawled out to allow for other bees to fan their wings and ventilate the hive to try and bring the brood nest temperature down to this magic number of 93 degrees. They were not capping off any honey during the drought because they were eating it as soon as they kind of manufacture it. They bring the nectar in, they incorporate their enzymes into it, they evaporate the moisture down to 18%, and then they cap it, which is what comb honey is, capped honey. They were eating everything they were bringing in during the drought. All animals need water. Beekeepers need to always make sure their bees have a water source nearby. Ours were dependably found on our pond. When the pond went dry in 2020, we had to make sure we went and bought a bird bath. We put out rain gutter runners and filled them with stones so that bees can drown very easily. They breathe through their abdomens, their exoskeletons, and if they get water in there, they can drown. So there's a lot of things beekeepers learn about insects that you would never really have the opportunity to even begin to understand, but they're fascinating animals. They seem to be quite intelligent, but we'll see how well they manage living up here. They do survive in the South, but it's going to be a whole different ball game if bees if queens stop laying in the middle of summer. They did kick in again. I had 8 colonies going to winter and 6 made it to spring, which is a survival rate of 75% across the nation. Beekeepers are losing 45% of their colonies over winter. So these good northern bees, they can do it. And it's pretty exciting when you see them do it. I just wanted to point out, these are not native insects. These eat bees. I hate these things. I've never seen the European hornet, but I heard that they're here. I do have trouble with the German yellow jacket, the European paper wasp, and the bald-faced hornet. I took this picture of one of them sticking their tongue out at me through the window. I had just gone out there and put out one of these funky little wasp traps that never worked. And I went over to the window to look out to see, and she's looking right back at me. So they're killers. However, the most successful way I've been able to control their populations so they don't eat my bees is to plant things in the yard that invite birds in, because the queens fly at colder temperatures in the spring, and they're out mating during the cold temperatures of spring, and they're very big and visible, so the birds just keep them under control for me. This last fall was I think the first fall I didn't lose a colony to wasps. And another thing is, if things warm up around here, I don't know, they know what a beehive is. They're very savvy about using a beehive like a little grocery store. But it's going to change the dynamic. And so I think I've touched on this, that they do keep honeybees in managed hives if it's done responsibly. They provide a food source for carnivorous insects like dragonflies and wasps, for birds and mammals. In these projects where they've done studies, they interact very well with native insects. And this is the field where I think it's about 10 acres or so that was mowed routinely, but I was able to keep the area behind my beehives wild, and it just came to life. It's just amazing the life that will show up. And then this is a Japanese knotweed plant in my backyard, which isn't invasive. It feeds an awful lot of insects. You can see bees, wasps, sweat bees. There were butterflies on this. It does not provide pollen, it provides nectar, a very high antioxidant nectar. A lot of beekeepers think knotweed gets their bees through the winter. If you are going to eliminate, keep in mind that the stems are hollow, and these native bees use hollow stems to raise their young. So you'd need to be very careful about the time of year you eliminated it, and you'd need to be very careful about how you did it. And I'm not a botanist or an expert on these things, but I would recommend that you look up what the current recommendations are without using chemicals. And plant something to take its place. One of my students did a wonderful thing and planted buckwheat in successive, buckwheat's an annual, but it's a relative of the knotweed, and it also produces an incredibly high antioxidant nectar. And so it's a wonderful supplement to a garden. And what they did was they grew buckwheat in successive plantings, skirting these little unmowed areas of their land to provide their bees with that option. Be careful about buying plants from commercial growers because they usually always have chemicals in them. And also take care that you're not bringing in insects from other places. This to me was a horror, that there are beneficial insects being sold, like parasitic flies, which certainly can be problematic. So do your research and be careful about what you bring into an environment. And so I think we probably all know about neonicotinoids. I will send a link to that. This is Kirsten Trainer's talk. And that's it, the end. I'm sorry I went over, I'm pretty sure. But I'll take questions. Hopefully I can answer them.
Thank you so much. Can I ask a question while everybody, does somebody have a question that they'd like to start with? You could raise your hand, or you can unmute or type it in the chat. Well, I'm going to ask a question. Did somebody raise a hand? I was curious, for people that are going to do some mowing, whether there's a better times of day, if there are times when there's, fewer insects, or insects are quieter, or more likely to be out of the fields and lawns, or.
Absolutely. Well, I would never, if you have to mow when plants are in bloom, you want to mow when it's cool out. And for honeybees, that's, below 50 degrees or even 55. They can't comfortably fly below 57 degrees, but if their muscles are all warmed out, they will be out there. And just observe, be aware of what you're seeing in a field or in your lawn, and try and pay attention to the time of day that those insects are out there. And usually once the sun is dipped below the trees, it's still light out. but you could mow, and the prime time, depending on the plant, like buckwheat provides the best nectar first thing in the morning, early in the morning. And I'll be surprised sometimes to see my bees out when it's in the 40s. But generally speaking, they're out between 10 and 2. So I would say anytime after 4. One thing beekeepers are familiar with is the young bees practice flying at about 4 in the afternoon. And Professor Seeley discovered, or he observed, that he thought that they were being rousted out by the guard bees at a prime time for them to be practicing, because there wasn't a lot of foraging traffic going on. So late in the afternoon would be a good time to mow.
Thank you. Do other people have questions? I will say that, Athena, if you're willing to send me these resources that you've talked about, the different links, I can both put them, I can make a post on the website and put them into an email to send to everybody who signed up.
Okay.
So that we'll have them all in one place. Let's see, there's a comment from Lynn. I leave my gardens alone until spring, so insects can use the leftovers for hibernating. When is it safe to clean them out in the spring?
Boy, good question. I'm not an entomologist, and I think all species have their own routines. But I'm always thinking about, I always wait until May 1st before I even go into my hives. I leave them alone until May 1st. I want to make sure they're well on their way. And I would think if honeybees are a little behind the calendar because they don't fly at the cold temperatures of other insects. So that might be a good gauge. I don't know for sure, but May 1st might be a good date. It's
So
the date I use.
That more insects have emerged from.
Yeah,
bird.
they all emerge at different times under different circumstances. But I feel like up here in our climate, my bees last week were acting like it was May. And we have a joke that beekeepers up here know that March doesn't come until May. So I never take it for granted. These warm-ups can throw you for a loop. So I just leave them alone until May 1st.
Any other questions?
I wouldn't mind if somebody had some insights to offer that I might have missed or gotten wrong. I'm open to being corrected, I guess I should say. So.
Mary says, I appreciate knowing that introduced species and invasives have a place and role in our ecosystem. Yeah, I'm interested in changing the language around invasives to talk about what the plants actually do, because so many of them, humans don't want them in some situation, but in other situations, for instance, if you have a lot of bees, then your knotweed becomes really beneficial.
They're successful for a reason. It's because they're getting attention from the insects.
Yeah, that's an interesting way to think about it too, that they're interacting in that way. I loved that you're thinking so much about ways to let nature be integrated, to plant food for birds if you're trying to control the wasp population.
Oh, yeah.
Yeah.
There was another beekeeper. She's been blogging for about as many years as I've been a beekeeper. She has a website, honeybeesweet.com. She actually graduated from the University of Montana as well. And she said she's got some cute posts about chasing down wasps and using everything from butterfly nets to every trap ever sold on the market. And I think that was her lead was let the birds do it and do it in the spring, because that's when the queens, yeah. And it was really shocking to me to find out how these wasps that I'm most concerned about aren't native. They aren't native insects. So I thought, well, I'm providing food for native insects, native wasps. They're eating my bees, but they're not native. So it's so I think so beyond our full complete understanding, you know. But like I've said, and I've been told that all we can do is the best we can with what we know.
Any final words? Anybody? Athena, thank you so much.
I hope it was useful information. I really enjoyed preparing for it.
Yeah, I appreciate it so much, and I'll follow up with you and put all the resources together. And you can see there's some thank yous coming in.
Oh, great, thank you.
Yeah.
And that link, Juno, I think I sent you a private message with the link to that newsletter.
Yeah, I'm going to put that in right now, and then I'll also put that in something to send to everybody with your other resources.
Great. Thanks for having me, everyone. Appreciate it.
Here. Yeah, beautiful photographs.
Oh.
Thank you so much,
All
Athena.
right. Have a good evening.
Let's see, I'm gonna